Hello friends, moving on to the next question. Measuring zeta potential is useful in determining which property of colloidal solution. Of course, the stability. The charge and solvation indicate stability. Also, the formation of double layer infers stability to the colloids. This is because formation of double layer will result in organization of charges. So when a similar ion come adjacent to this molecule or this this particular solid, so these have a positive charge on its outer layer, even that will have a positive charge on outer layer. So the molecules or the ions will ripple, the solid particles will start rippling each other, and they do not tend to form a colloid. They remain as colloid and they do not tend to form a precipitate, so it will remain colloid. So zeta potential is useful in determining colloid stability of the colloidal particles, not the size, not the viscosity, not the solubility. Which of the following oxo acid has peroxide linkage? This kind of linkage is called peroxide linkage. You could directly find this peroxide linkage in peroxo disulfuric acid and oxo acids of sulfur. If you cannot, you could also use the structure at this time. So first write sulfur on both sides. One, since there are two hydrogens, one definitely will be an hydroxyl group and the other one will be double O. So 1, 2, 3. You would still have three valencies to be satisfied. Could check. 1, 2, 3, 4, 5, 6, 7, 8 oxygen atoms, 2 hydrogen atoms, 2 sulfur atoms has peroxide linkage. So moving on to the next question. 166. The mixture which shows positive deviation from Raoult's law. Again a direct statement. It's based on memory. It's a memory based one. For positive deviation, in case of positive deviation, the intermolecular attractive forces between the solute molecules and solvent molecules are weaker than those between the solute and solvent molecules, hence it is called positive deviation. You could observe that the vapor pressure is greater than the actual pressure. So the example is mixture of ethanol and acetone. Direct. Next question, the calculated spin only magnetic momentum of Cr2 plus ion. The first thing you have to know is the spin only formula, which is mu equal to root n into n plus 2, where n is the number of unpaired electrons. For Cr2 plus, Cr will generally have the formula 3d5 4s1. After turning into an ion, it will have 3d4. So root over 4 into 4 plus 2, which is 6. 6 4s are 24, root 24. Root 25 is 5. So root 24 will be approximately close to 5. So which is 4.9. And this question, the freezing point depression of benzene is 5.12 Kelvin kg per mole. You also have to be confident about the solvent that is involved. Kf is meant for the solvent. Supposing solute and solvent both are given and Kf values of both of them are given, you have to go for the Kf value of the solvent, not for the solute. The freezing point depression for the solution of molality 0.078 m containing a non-electrolyte solute in benzene. So benzene is the solvent. Rounded off up to 2 decimal places. Just use the formula delta Tf equal to Kf into m. Non-electrolyte solvent will have I equal to 1. Solute will have I equal to 1. Non-electrolyte solute will have Van't Hoff factor as 1. So delta Tf equal to I into Kf into m. Always remember Van't Hoff factor. After writing Van't Hoff factor, you can neglect by writing 1 as Van't Hoff factor multiplied by Kf, which is provided, and molality is also provided, and delta TF is the answer. You will get it as 0.4. Moving on to the next question. Identify the incorrect statement. The transition metals and their compounds are known for their catalytic activity due to their ability to adopt multiple oxidation states and to form complexes. Correct. Interstitial compounds are those that are formed when small atoms are trapped inside crystal lattices of metals. Again, correct. Also, this is a correct statement. So the oxidation states are not equal is a wrong statement because oxidation states are equal. So let's check it out for this. Are not the same is the given statement, but CrO4 2 minus X plus of 4 into minus 2 equal to minus 2. So x minus 8 equal to minus 2, x equal to plus 6. Similarly, check it for Cr2O7 2 minus, so plus 7 of minus 2 equal to minus 2. So 2x minus 14 equal to minus 2, or 2x equal to 12, x equal to plus 6. They both have same oxidation state, but given they don't have the same oxidation state. Hence, it's a wrong statement. Hydrolysis of sucrose is given by the following reaction. Equilibrium constant given, temperature given, the value of delta Rg at the same temperature. So direct formula, we know that delta Rg not equal to minus RT ln K. The value of R is minus 8.314 joule per mole Kelvin or Kelvin mole multiplied by temperature into ln Kc, and that's the answer, direct one. Which of the following is the correct order of increasing field strength of ligands to form coordination compounds? It's a memory based question. A direct answer is also provided in NCERT, so I would advise you to remember this spectrochemical series. So next question. The number of Faradays required to produce 20 gram of calcium from molten calcium chloride atomic mass. The first thing we have to check is the charge on the atom which is to be produced. So the charge is Ca2 plus. The number of charge is number of Faradays required. For forming 1 mole of calcium, you require 2 Faraday electricity. Faraday is a unit of electricity, other unit of electricity. 1 mole, it is also given that 1 mole will weigh 40 gram. 40 gram, 2 farad is required. For 20 gram, obviously 1 farad is required. Hence the answer is 1. And thank you friends.